All right, in this video, we are going to talk about finding areas underneath normal curves. Remember, we talked about for continuous random variables that finding probabilities or percentages that lie in a given range, what you have to do is find the area underneath the density curve or the normal curve in this case and above the x-axis between the given range. And we were using geometric formulas like the formula for the area of a rectangle and the formula for the area of a triangle to calculate those areas previously. But with a normal curve, those are not, standard geometric shapes like we are used to. So how do we find the areas under the normal curves? And so, as I mentioned previously, mathematically, that's a pretty difficult problem. What we are going to do is to use the standard normal distribution and z-scores to find those areas. And then we will see that Desmos also is really good at kicking out those probabilities for us. So, all right. So the first thing that we need to talk about are what are called z-scores. So if I have a normally distributed random variable x, and this is a capital X, right? And it has mean mu. Remember, that's the Greek letter mu, which is kind of like a Greek version of the letter m, and standard deviation sigma, right? That's the lowercase letter, Greek letter sigma, which is kind of like a lowercase s. Then the random variable z, and that's a capital Z defined by cap z equals cap x minus mu divided by sigma, has the standard normal distribution. Okay, so if we have this variable x and it has a normal distribution, and then if we subtract off mu and then divide by sigma, that means that and call that z, that means this variable z will have a standard normal distribution, and that is the normal distribution that has mean 0 and standard deviation 1. And so you can kind of see here, just to kind of explain why maybe that's so, is remember this variable x, right? If it has mean mu, then it will be centered at mu, and by subtracting off mu, you're basically moving that to 0, right? The mean to 0. And then by dividing by sigma, you are sort of scaling everything down. So let's take a look on Desmos and see if we can illustrate that. So on Desmos, it is normal dist. And let's just say we had a mean of 4 and a standard deviation of 2. Okay, that's what it would look like. All right, and so then if we subtract off 4 in here, you're going to see that basically that takes and shifts the old curve. Let me draw the old curve here, the one that we started with. The red one. You're going to see the effect that that has is that it shifts that center right to 0 here, which is the same as the standard normal distribution. And then finally, when you are dividing by the standard deviation of the original one, which is 2, right? That will make this number in here so that it's 0, right? And this number in here so that it is 1. So in effect, what you're kind of doing is scaling the original distribution and shifting it over and then scaling it so that it has the mean at 0 and then it has a standard deviation of 1. Okay? And so that's kind of what the z random variable is. If you have a value of a normally distributed random variable x that has mean mu and standard deviation sigma, then the z-score for that value of x is x, lowercase x, that's the value of the random variable, minus the mean divided by the standard deviation. So basically what this is, it will tell you where, when you're doing this scaling, shifting and scaling that we talked about, basically where a number x will wind up at on the scaled distribution. Okay. All right, so let's take a look at an example of that. First, before we get into that example, then what we will do is explain how we are going to use z-scores, right, for finding areas underneath the curve. So basically what this does, the z-score does, is it reduces the problem of finding the area underneath any normal curve, and there's bunches of different normal curves as we've illustrated before. It boils it down so that you only have to find the area underneath the normal standard curve. Okay, that's the one with mean 0 and 1. So all you have to do is to do that, and you'll get the correct answer. So instead of having to look at tons and tons of different normal curves, through the z-scores, it allows you to only really, all you have to do is focus on the standard normal. So it'll take your problem that you're working on with some random, some normal curve with any mean or mu, and it will basically translate that into a problem of finding the area under the standard normal curve. And that also is a typo here. That should say section 6.2. That we're going to learn how to do that. So we already did 7.2, and that was about something else. So that should be 6.2 there. Okay, now let's take a look at a specific example. All right, so here we have, oops, sorry, went ahead too far. Here we have a normal curve. Okay, and that normal curve has mean 3. You can see right there, it's centered at 3, and it has standard deviation 2. And what we want to do is to, let's just say we want to define the area from 1 to 4. Okay, so that would be the area of this little blue shaded region, and we don't have a nice neat geometric formula to figure that out, what that area is. So what we are going to do is to calculate the z-scores for 1 and 4. Okay, so we're going to do that, and that's be on the next page. So, all right, so we're going to calculate the z-scores for 1 and 4, and our formula for the z-score, right, is z equals x minus mu over sigma. We know we were given, right, that mu is 3 and sigma was 2. So for this problem, our formula for the z-scores is this: z equals x minus 3 over 2. Okay, so now to get the z-score for 1, what we would do is plug in 1 in for x. Okay, so we get 1 minus 3 over 2. That's negative 2 over 2, and that's equal to negative 1. Okay. All right, so that would be the z-score for the x value of 1. Next up, we want the z-score for the x value of 4. So we would plug a 4, right, into our formula here for the z-score. So that'd be 4 minus 3 over 2. That's 1/2. Okay. All right, and so now what that is that area that we wanted to find before, right, was here. We wanted to find the area from 1 to 4 on that normal curve that we had, the one with mean 3 and standard deviation 2. That will be the same as finding the area from underneath the standard normal curve. That's the one with mean 0, right, and standard deviation 1. Not from 1 to 4, but from negative 1 to 1/2. The z-score of 1, right, was negative 1. So that means this area will start at negative 1. And the z-score at 4, right, will start at, will be at 1/2 right here. Okay? And so now we have very pretty efficient ways of finding the areas underneath these normal curves. And so for the standard normal. So basically we take this problem here that we had for finding the normal curve here, we translate it over into this problem about the standard normal curve.